Okay, let's do an example of what we talked about in the introduction slide. Uh, what we're going to do is we're going to flip a coin 2 times, and we want to ask a few questions about what we might observe. In particular, we want to know the probability of getting exactly one head in 2 tosses, and then we also want to know the probability of getting at least one head in 2 tosses. We will use the ideas of classical probability, and we will assume that a coin is fair in this instance. The first step is we need to describe the experiment carefully. So one way of doing that is to draw pictures when possible. A common thing that we might draw is what is called a tree. A tree diagram like the one you see on the slide represents how we might visualize the experiment. That is, the first toss we can get a heads or we can get a tails. And then after the first toss, we can get a heads followed by another head, or we can get a head followed by a tail. Similarly, if we got tails on the first throw, we can go tails, tails. Whoops. Excuse me, tails, tails, or tails, heads. An important thing to understand here is we are reading left to right. So HH is heads, heads, HT is H tails, tails, heads, tails, tails. Order is extremely important. So the next thing we always want to do is, if possible, write out the sample space. As we've mentioned previously, this experiment has 4 outcomes. The 4 outcomes are heads, 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 tails, tails, heads, or tails, tails. It is convention in mathematics to write your outcomes using what we call set notation. You'll see these braces, these brackets here, and we list the 4 outcomes, and we call this set S because it's called the sample space. Okay, so the first question we were asked is, what is the probability we get exactly one head? So to answer this question, we look at this event where there's exactly one head. This can occur in 2 different ways. We can either get heads, tails, or tails, heads. And there are 2 of those. And so the probability of exactly one head is 2 divided by 4, or 1/2. So we saw that the probability of getting exactly one head is 1/2. But what about the probability of getting at least one head? Well, for this particular question, there are 3 outcomes we're interested in. Heads, heads gives us at least one head. Heads, tails, and tails, heads. And so the probability of at least one head is 3/4, or 75%. Okay, to recap, the probability of exactly one head is 2/4 because there are 2 outcomes that are favorable, and there's 4 total. And then similarly, for at least one head, there are 3 favorable outcomes, so we get 3/4. Okay, this final slide summarizes the results of the example we just did. An important thing to keep in mind here is that when outcomes are equally likely, as they were in this example, assigning probabilities comes down to nothing more than counting. So we will use these ideas to solve lots of problems throughout the remainder of this term. So my advice to you is to make sure you can do this example and one similar to it. please reach out to me if you have any questions. I am happy to assist in person, virtually, whatever it takes to help you guys learn this stuff. All right, till the next time, my peoples. Peace.